Welcome to another key session on large language models, LLMs, and related technologies. These videos are designed to sharpen your knowledge and prepare you for interviews in today's competitive job market. Each video includes a free self-evaluation quiz, and for our interns, we provide exclusive Anki flashcards to help you master and retain these concepts effectively. Let's get started. Wishing you the very best in your learning journey.
Have you ever stopped to wonder how your phone knows it's you and unlocks instantly? Or how a self-driving car can navigate a busy street? Well, it's not magic. It's an amazing piece of tech that's designed to teach computers how to see the world much like we do. Today, we're diving deep into that very technology, the convolutional neural network. So here's our game plan. First, we'll get a handle on the basic problem, how a computer even begins to understand a picture. Then we'll introduce the star of our show, the CNN, and look at its key parts. After that, we'll watch those parts work together in real time, turning a simple image into a smart prediction. And finally, we'll wrap it all up with the one big idea you'll want to take away from all this. All right, let's kick things off with the fundamental challenge. When you and I see a picture, we see objects, faces, scenes, but a computer, it just sees a giant grid of numbers, a bunch of pixel values. It has no idea what a cat or a car is. So the real question is, how do we get a machine to go from seeing just numbers to actually understanding what's in the image? Let's make this real with the classic internet challenge, cat versus dog. How does a computer learn to tell the difference? Is it the pointy ears, the shape of the snout, the texture of the fur? And more importantly, how can it learn to piece all those little clues together to make a final, confident call? This right here, this is the exact puzzle that convolutional neural networks were born to solve. And the answer to that puzzle is a really clever and powerful tool that was built specifically for this kind of job. It's called a convolutional neural network, or CNN for short. So what's the big deal with CNNs? Well, unlike other types of neural networks that just get a long, flat list of data, a CNN is smart. It's built from the ground up to understand that an image has structure. It knows that pixels next to each other are related, and it uses that knowledge to find patterns, shapes, and eventually whole objects. The secret sauce of a CNN really comes down to two powerful ideas. The first is spatial locality. That just means it assumes nearby pixels are part of the same thing. Simple, right? That's why it scans an image with tiny filters, looking for local patterns. The second idea is translation invariance. This means that a cat is a cat whether it's in the top left corner or the bottom right. The network is designed to recognize an object no matter where it appears in the picture, which makes it incredibly efficient and powerful.
A great way to think about a CNN is like a visual assembly line. An image goes in one end, it gets processed at different stations, and a final decision pops out the other end. So now, let's go meet the workers at each of those stations.
Okay, here's our crew. The heavy lifters are the convolutional layers. Think of them as feature detectors, scanning the image for basic stuff like edges, corners, and colors. Once they find something, the pooling layers often step in to simplify things. They basically say, hey, we found an edge in this general area, which makes everything more manageable. Then you have activation functions. These are super important because they help the network learn complex patterns. Without them, the whole system would be way too simple. And finally, after all the features have been pulled out, the fully connected layers act like a final committee, looking at all the evidence to make a decision. Oh, and dropout? That's a clever little trick that prevents the network from just memorizing the training images by randomly telling some workers to take a break. All right, now that we've met the team, let's watch them work together. We're gonna follow an image as it travels down this digital assembly line, all the way from raw pixels to a final intelligent prediction. And here we go. The image enters the system. It immediately hits the first convolutional layers, which start spotting basic features, lines, curves, edges. That information gets passed on and simplified by pooling. Then it hits another set of layers, which combine those simple edges into more complex ideas, like ear or whisker. This can happen several times. After all that feature spotting, the final map of features is flattened into one long vector of data. This vector is fed into the fully connected layers, which weigh all the evidence. And from there, it's on to the output layer for the final verdict. And voila, here's our result. The network doesn't just give a simple yes or no, it gives us probabilities. Based on all the features it found, the pointy ears, the whiskers, the shape of the face, it's calculated that there's an 85% chance this is a cat and maybe a 15% chance it's a dog. The highest probability wins, and the machine has made its choice. So, we've seen all the moving parts. Let's zoom back out for a second and lock in the single most important idea. When you think of a CNN, what's the one thing you should remember? This quote absolutely nails it. At their heart, CNNs are feature extractors that build understanding from the ground up. It's almost like how we learn to see. They start small, spotting the simplest patterns, an edge here, a color there. Then, through training, they learn how to combine those simple patterns into more and more complex ideas. They go from line to circle to eye, and finally, to cat. So, we've managed to give machines a kind of sight. It's a technology that's already changing everything, from medicine to how we get around. The possibilities are just staggering. And that leaves us with a really exciting question to think about. Now that our machines can see, what new things are they going to show us about our world?
Thank you for watching till the end. Don't forget to test your knowledge with the quick self-evaluation quiz. The link is right in the description. If you found this video helpful, please like, share, and subscribe to support the channel. And if you haven't yet explored our self-paced AI internship program, visit shogini.com for full details. Wishing you all the best in your AI journey.